Hello, everyone, and welcome to Module 3, Part 1. I think I'm going to rearrange how I'm organizing these. We're spending a bit more time on these early modules, which is good. That's a good thing. But I want it to be less confusing. But anyway, we're focusing on data cleansing for the next probably 2 to 3 weeks because there's a lot here to go over. It is quite different than normal data cleansing when you're doing an analysis in Excel or SAS or whatever program you've used before. Text can be very specific and also very open-ended. So it allows a lot of creativity, and it can be a little frustrating for people because there's not a set do A, B, and C and you're done. It's a lot more about asking questions and understanding your objective, your research objective, your business objective, whatever it may be. So we're going to jump in now. For this module, some learning objectives, you'll notice that first one is something we're going to focus on throughout this term. So identifying relevant sources of unstructured data for various areas of interest and explaining questions that can be answered. So understanding what data is out there, what it can be used for, and how we go about putting A and B together. We're going to recognize basic steps in a text tokenization pipeline. That sounds super fancy, but you are going to learn how we do that by the end of this video. We're going to compare different vectorization algorithms and parameter settings. We're going to start getting into that this week, but we're really going to dive into that next week and in week 3 of this module. And then recognize alternatives for creating numeric representations of text. So creating numeric representations of text. That means we're going to take text, and because we're data people, we like numbers, we're going to convert it into numbers, but there's many ways to do that. So we're going to explore lots of them. So again, with unstructured data, text data, we need to take this text that is not structured, which it's not just that it's not an Excel file, it's not in rows and columns. It's that a text can be many different things. So for example, if I have a traditional structured data set, I might have name in one column, and age, and gender, and address. But in text, it's all going to be kind of jumbled in there. So we need to figure out how to pull out those relevant bits of information, organize it, and then analyze it after. So the trick with unstructured data is that we actually don't want to deal with it. We want structured data. So again, we have text in documents, websites, social media. We've got things like, especially on social media, you see how people speak differently. We've got differences in speech and context. So think about, I always give the example of fireflies and lightning bugs. You know, people say things differently. And then we also have the nuance of sarcasm and emojis and all of these other things we use to go along with our text to make sure people understand what we're saying. We need to take that all into consideration. But to do that, we have to take a step back and understand what data do we actually want, and we want structured data. So even though we have text, which is kind of all jumbled and it's got varying lengths and sizes and all these things, we want it in rows and columns. And we want to understand the metadata, so the data about the data. So where did the text come from? Can we measure frequency of certain pieces of text, the presence or the absence of text, the distinctiveness, so how unique is the text, the words that we're using? And we're going to get into that this week. So I liked this, I can't remember where I found this now, it might be in the notes of these slides, but I really liked this graphic of the text cleaning process. So we're starting with the source text. And the first few weeks we dealt with website data. This week I'm going to just give you a CSV file, things you've used very often, and we're going to start from there. But this data cleansing process, and really we're getting into this linguistic processing this week as well. But for data cleansing, we want to identify and remove noise. So noise is things that we don't want in our data set, things that are taking away from the actual research question that we have. We want to normalize characters. You will notice in the data set we're using that that's not always possible. There's a lot of text that has like Russian characters, for example. None of us probably speak Russian, maybe some of you do. So we're going to deal less with that type and more about thinking about uppercase and lowercase. Maybe we make things, everything lowercase. Data masking, maybe we take things like, I think I used this example in this class when we talked about Arrowhead Stadium, for example, in Kansas City. Stadium and Arrowhead, they're both referring to the same thing. So maybe we would take out every reference of Arrowhead and just say stadium. And then supposedly we have clean text at the end of it. But really, the difference between clean text and prepared text is that linguistic processing layer. So some of the things we're going to look at this week are things like tokenization. So remember, with text, our data set is really a corpus. And then we have our documents, so our rows. But each column in a data set, in this case, it's going to be a token. So instead of an entire book, might be our corpus. Each chapter might be our document, but each word on that page is going to be a token. We're also going to look into POS tagging, so part of speech tagging, probably next week. Lemmatization next week, named entity recognition a little bit, not quite as much. And then we get to that prepared text. So we are taking this varied text with lots of nuance and difference in capitalization and things like read and reading and will read. We're going to combine all of those into the same part of speech. We're going to try to make things as normalized as possible so that when we analyze this data set, it is as clean as we can get it. So for example, I know you all have group chats, and I'm sure your group chats look just like this, where you're saying math is cool, data science is fun, Python is fun too, but you've got all these texts. So in this case, the corpus is our group text, a document is a single text message, and a token is a single word within a text message. Now, when we are doing vectorization, which we will be doing in a moment, we want to take these texts and basically put them in a data set, a data frame with rows and columns. So what might this look like is right here. So a vectorization output is a numeric representation of that text. And we call this a sparse matrix. Some of you may have taken linear algebra, but if you haven't, that's okay. A sparse matrix is a matrix, so basically a data set, rows and columns. We call it sparse because most of these are going to be zeros. In this case, it's just blank, so you can see it. It's not necessarily binary, so it's not just ones and zeros. We have threes here, but for the most part, we've got rows and columns, and we only indicate where there's a presence of a word. So in this case, we've got math is cool. So cool is in math, all have ones. Data science is fun. Data fun is in science, and so on. And then when we get down to data, it's 3 in this data column. And for now, the shape of our data set, so the size of it, it's 6 rows and 11 columns. So that shape 611, that's saying rows and columns. So that's a good starting point. We've taken text, we've vectorized it, so we've made it into rows and columns, and now we have a 6x11 data set. But there are things we might change about this. So for example, actually, I'll get into this one first before I tell you that. So vectorization, it produces that sparse matrix. A majority of the items in there are going to be a 0. Not all of them. There's got to be something in there to tell you what's going on. But we've got rows that are observations, columns that are features. I believe you've taken predictive modeling. So features, like features that you'd use in a predictive model. And then another kind of fun term we use for this is bag of words. So all of the columns in there, they're a bag of words. And then the interpretation, that's where we really get into the nuance of text. And that really brings about the creativity. And this is where some people are like, no, just give me a set of rules and I'll follow those rules and analyze the text. And unfortunately, there's not a lot of strict rules with text. It's all about this interpretation and what you're trying to achieve with the text. So that all being said, take your time and really think about what are you trying to answer and where did the text come from? So in this case, we've got, remember that 6x11 matrix. When we start doing feature engineering, now in traditional predictive modeling, we are thinking about what is going to influence that target variable the most. In this case, we are even going to take a step back and say, what features do we have and which ones are maybe not so important? So if you take a look at this, so let's start with cool, probably useful, data, okay, fun. We get to is. Is might not be the most relevant part of this data set. You see almost every single text has is in it. Is doesn't give you much information. It's a filler word. We call it a stop word. So maybe we think about doing something like that. You'll notice math capitalized and math lowercase. Those are two different columns. So maybe we do something with that. No and not. Maybe we do something there. You see, you kind of see how we go. We look at how can we combine columns? How can we remove columns that are not necessary so that we can focus on what's important to our data set? And that's basically what I just said. So case, do we need to worry about case, uppercase, lowercase? Should we take out punctuation? A lot of times, yes. Are all of the terms informative? So those stop words, is, of, and, the, we need them to be able to speak like human beings and not sound like Cookie Monster. But do we really need them in this case where we're trying to understand the usage of text? So here's one where we've taken out, so we've taken out the filler words, so is and to, and we've made everything lowercase. So that means we no longer have that uppercase math, and now math is here, and you notice that uppercase, lowercase, it doesn't matter. Now we just know that there's two instances of math there. So instead of a 6x11 matrix, we now have a 6x8. So you see how that's slowly shrinking down our data set because we want to focus on what's most important. We don't want to waste our time with text that's capitalized and not, and we want to put them all together. We don't want to leave in filler words, is, and to, and the. Let's take that out. Again, let's just focus on what's important. And with that, I'm going to walk you through the code for this week. So a few terms that we're looking at this week, we've got tokenization, which is we are taking text and we're dividing it into tokens. I say might be a word, might not. It's almost always a word. That's really our basis, our unit for tokens. We've got vectorizer. So we are going to vectorize something, which sounds really crazy and scientific. It is taking text and we're going to make columns out of it. And then we've got our feature space. So once we understand our rows and columns, let's see if we should shrink it down or change it and really understand what's there. So for our setup, and in this week, I bring up a few different vectorizers. We're only using one. It is called Count Vectorizer. So first, you are going to import your packages. If you all ever get an error importing these packages, it's likely that you don't have something installed. So for example, if you got one with this, it might mean that you haven't installed scikit-learn yet. All you'd have to do is insert a cell, do an exclamation, which is saying run this as a computer function, not as a Python code, and do pip install. I don't know how they spell it. Something like that. Whatever your package name is, you would put that there. So for example, last week we used Beautiful Soup 4. And you see it's already satisfied because I already have it installed. but that's just how you install packages in Jupyter. So you don't have to leave here. You can do it all here. So we are going to be using a new data set this week. It is the BBC News data set, and I have downloaded it from Kaggle, great data source for data sets, great website for that. And this data set is on Brightspace, so go ahead and download that before you do this, and make sure to save this to your Python folder. So you see here, I am just reading in this data set and saying, hey, go get me this BBC News CSV. If it's not in your folder where you've created this notebook, it's not going to know where your file is. So just save it wherever you're saving this notebook. And I'm going to, again, when I'm running this, you can either press the run button or I am pressing Shift and Enter. So I've read in my data set. You saw it just took a few seconds. Here's what it looks like. So it's got a title, a publication date, a GUI ID, which in this case is actually the short link, and then a link that kind of gives it more information, things like campaign and stuff, and then a description of the article. So this first one, it's about Ukraine. A lot of these are going to be really depressing because it's the news, so sorry in advance. Ukrainian president says the country will not forgive or forget those who murder civilians. So we've got our title, when it was published, and a little bit of a descriptor of what that article was about. And now if we want to see this, I'm doing df.shape. And so I had named my file df for data frame. That's almost always what I'm going to name my data sets. And I'm going to just say shape, which says, give me the size of my data set. And it is 34,072 rows and 5 columns. So that makes sense, right? We've got our 5 columns here, and we've got over 34,000 rows. So we're getting into a little bit more data now. I've included lots of links in this file, so you can look through and look at the different methods we're using, the different technologies. But I'll keep this part short. We are looking at vectorizers, and specifically, we are looking at the count vectorizer from scikit-learn. So I said a lot of words, but scikit-learn is the package. It's open source. It's what most people use for data science in Python. And count vectorizer. We are vectorizing, so we're taking text and making it into rows and columns. And it's a count vectorizer because we are looking at the count of texts. There's another one we will go over next week, but I'm going to pause on that. So a count vectorizer has many parameters, and your homework this week is actually looking at these parameters and understanding how it works. So I do recommend starting up here with this link right here. And it brings up the entire documentation for this package. And in particular, it tells you about these parameters. So some of them are going to be defaults. So things like your input, your encoding, it's almost always UTF-8. You don't even need to know what that is. It's just that's the default for text. Strip accents. So right now the default is none. So we're not stripping accents. Maybe you want to. Lowercase, the default is true. And you can start to see, you see the default, you see what type of parameter it is. So this is bool, which means Boolean, true or false. And then it'll tell you what it does. So in this case, it converts all characters to lowercase before tokenizing. So remember that math and capitalized math where it was 2 different columns, we won't have that as long as we use this lowercase and we don't change anything because the default is already true. It's going to make everything lowercase. So back over to our code. These are the parameters. I'm going to start off with one, and all you have to do to define your method is create a variable. I am calling it CV1 for count vectorizer 1, and I am saying count vectorizer binary equals false. So if you're wondering what that means, so count vectorizer binary equals false. You can come over here and say, okay, where's my binary? The default is false, so I didn't really do anything by specifying. But if true, all non-zero counts are set to 1. This is useful for discrete probabilistic models that model binary events rather than integer counts. That is a fancy way of saying, if I say math 3 times, or I guess the word was data in that other one. If I say data 3 times, it's still a 1. So it's 1 if it exists and 0 if it doesn't. But in this case, binary equals false, which means it's going to just count. It's going to count how many times a word is used, and that's all. And a comment in here, notice that we did not specify a data source. That means CV1, that count vectorizer binary equals false. We can use that anytime. We can use it on any data set that we use throughout this, but because we've initialized it, instantiated it, whatever word you want to use, it is there and we can use it. Now to actually apply it to our data set, we are going to say, I like to name the output from this. So I'm going to take CV1, so that count vectorizer. I want you to transform the description columns, the description of the article, transform it using this count vectorizer, and name that output CV1 news. And actually, when I do this, let me see. So you can actually see that CV1 news, it's a sparse matrix. So exactly what we just talked about. We're taking our data set, running it through a vectorizer, and we get a sparse matrix. Now I can print the shape of this so we can understand how many tokens we have. So we still have that 34,072 rows, but now instead of 5 columns, we actually have over 28,000. So it has taken all of these tokens, all these words, and it's basically saying at this point, we have 28,622 unique words in this entire data set. Really big, so we might think about cleaning it at some point. By running this cv1.get feature names out, I'm gonna get my feature names. You're gonna notice it only shows you a few of these. There are ways to get around that. I have not put it in this code, or else I know I'm gonna get your homework and it's gonna have 28,000 records. So just know there are over 28,000 tokens. We might pause and not print all of those out yet. You can start to see that, so 00, that's a token. That means numbers count as tokens. Some of these are names and places, they are tokens, and you notice they have the accent marks in there. There's characters that are non-English, so that's something we'll have to deal with at some point. Now, what I like to do, so we have this sparse matrix. I don't want to just use that sparse matrix. I want to actually connect it back to our data set. So I'm going to say our count vectorizer data frame is a data frame where I've taken that sparse matrix, and I'm going to name all of the columns the features of the sparse matrix. And then it's going to take just a second because it's taking those 28,000, the 34,000 rows, and it's going to say, okay, wait, how do I make this into a nice new thing? And it concatenated, so it combined the original data set with that count vectorizer data set, and I just shoved them together. Every piece of code I have put on here for you, I truly want you to use as is as much as possible. Again, this is not a coding class. We're talking about the usage of text. So feel free to just take this code, and I've made it hopefully pretty easy for you to plug in your data and use it appropriately. So now we should have this nice new data set, and you see, so still the same angry Zelensky, the Ukrainian president says the country, blah, blah, blah. And now we have all these features. Again, I'm not going to change the settings yet so you can see all of the columns, but just know all 28,000 are definitely there. And we can double check by saying new df. Is it actually? Okay, I was making sure it was not news df. So new df.shape. And you'll notice here, you're only seeing a few columns over here, but they are all almost, yeah, all of them are 0. If I change this new df.head to, let's say, 25, I might eventually find one that's not a 0. both 28,000 tokens. Yeah, none of them yet. There are different settings to be able to see all of the columns, but like I said, we're going to focus just on the basic data set too. I'm hoping you can't hear my cat in the background. They hate when we're in meetings and have the door closed. So one of them's crying right now. All right, so that was count vectorizer with binary equals false. There are so many parameters we can change in here, and I have started you off with a few. For CV2, it's binary equals true. So remember, binary equals false means it's just going to count everything. Binary equals true means it's 1 if it's there, it's 0 if it's not. No numbers in between, higher, lower, anything. It's just ones and zeros. Count vectorizer, stop words equals English. Again, stop words. Let's go over here and say, let's find stop words. English, okay. So English, a built-in stop word list for English. And it doesn't really tell you as much, but I will tell you now. So if you're listening to the lecture, you get some extra tidbits. Stop words equals English means it's going to take all of the English stop words that it has, and it's going to remove them from the data set before tokenizing. Lowercase equals false. That means it's not going to make things lowercase. What is that going to do to our data set? Probably make it a lot bigger. And then finally, CV5 min df equals 0.1. So I'm going to go over here to show you. There's min df and max df. You can specify that a token has to appear 5 times before it counts, or that it can only appear a maximum of 50 times, and otherwise we're just going to leave it out. So really common words, take them out. What I like to do is actually use this float part. So a min df and I put 0.1. That means that a token has to appear in 10% of the documents, or else it is not used. In some cases, we might say 50%, or it has to be lower than 75%. So we'll use max df. So definitely look at these two and then kind of say what's going to happen when min df is 0.1. So I'm going to run these. I won't tell you too much because this is your homework. Fit transform. And now we're saying, okay, we've taken the data set. We have our vectorizers. What happens with the different parameters? So the first one had 28,622. The second one has 28,622. So think about it, binary equals false and binary equals true had the same number of tokens, but what's actually going to be different? The third one was stop words equals English. You'll notice the rows are the columns, sorry, are slightly less at 28,344. If we don't do lowercase and we leave everything case whatever it is, we get 32,112 columns. And then finally, if we say we only want words that are in at least 10% of the documents, we get 14. So kind of think about that, what might be going on. Your homework number 4 is all about taking these and describing it, what's going on. I tried to leave it less technical this week to give you a little bit of a break. I know you've been working hard on this. And then one last thing before I let you go is I'm going to show you in content. Now you will be able to see Python code snippets. I'm doing this to try to make it as easy as possible because again, this is not a Python class. I don't expect you to learn Python over the summer. I want to set you up for success so that you understand the technical aspects of what we're doing, but more so you understand the research questions and how we formulate text data. So this is a bunch of, and I'm going to add to this over time. But so for example, web scraping, that was the first couple of weeks. Importing packages, these are the packages you need. If you want text from a website, here's all the text to do that. The Avalon project, since it's a little easier, I also put that in there. Here's how to view a data frame. Here's how to modify a data frame. And then importing text from a document. So I didn't actually do the PDF part in this class because the PDFs I have just are not very good for text. But if you ever have text from a PDF and you want it out, this is exactly how you do it. And then what we learned today, so CSVs, how do you get text from a CSV? Just like this. So hopefully that helps. Like I said, I'm going to add to it over time. But I think that is it. So have a fantastic week and I will see you next time. Bye.